I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
We look to the past for inspiration.
We choose to go to the moon. We choose to go to the moon.
It's one small step for man, one giant leap for mankind.
And now a new generation of space explorers is on the rise. This is a time of true greatness, and it all starts here in the Students for the Exploration and Development of Space at Rice University.
If there's anybody on the face of the planet that can help explore and develop space, it's the mighty owls of Rice University.
Join SEDS Rice, where you can explore and develop the amazing world of space. Whether it's engineering CubeSats, networking and engaging with space professionals, or even having lunch with an astronaut, this is the place for you. You are the future of spaceflight. You are the next giant leap. Hello all and welcome. Thank you for joining us. My name is Ryan Udell and welcome to the 2021 Owls in Space Symposium at Rice University. This is an event put on for students by students to help you engage with space industry and culture. We welcome students and professionals from all over the country today, and we are proud to be able to continue this event in a virtual setting. This event wouldn't be possible today without the contribution of the amazing students in SEDS Rice, the Society of Women in Space Exploration, and Rice Eclipse rocketry team, including but not limited to Alex Stodola, Austin Williams, Justin Lee, Jack Sheehan, and Jeff Michelle. I would like to thank our club sponsor, Dr. David Alexander, and the Rice Space Institute for helping us put on this great event. I would also like to thank our wonderful supporters at Rice and our space industry professionals here today. Thank you. Before our main event, I want to give a brief background of who SEDS is, and Rice Eclipse will give a brief overview of who they are and what they do following our keynote speaker. After our Space in the 2030s and 40s panel, the link for the company booths will go live and you will be able to talk to SEDS Rice, Rice Eclipse, the Rice Space Institute, the Space Studies Master's Program, and over a dozen incredible companies, many of which are local to the Houston area. You can learn more about our upcoming panelists and speakers by navigating to the Live Sessions tab in Forager 1 Symposium. But let's begin. Despite the difficult semester that featured remote, in-person, and hybrid events and projects, SEDS Rice accomplished many items and is continuing its goal to empower students to engage in space disciplines, both at Rice and abroad. We do this by hosting events such as this symposium and projects to connect students with aerospace companies and technology. We currently have 3 active large-scale projects, including Rice's first CubeSat satellite, the NASA Human Exploration Challenge rover, and the NASA Lunabotics rover. The Human Exploration SWICE, our Lunabotics rover, and our next conference will be presented on more following the first panel. Additionally, the OwlSat CubeSat is a community satellite, and we want everyone, Rice alumni, students, and faculty, to submit their names to be nano-engraved to go on the satellite when it is launched to space. In the chat now, I am pasting the link for you to send your name on OwlSat to space. Additionally, last year, we made an announcement stating that the OwlSat CubeSat was selected for the NASA CubeSat Launch Initiative, securing a free ride to space. But this year, we have another massive announcement with the ALSAT CubeSat. I am proud to announce that SEDS Rice has selected Firefly Alpha, a rocket built in Texas, to launch ALSAT in the spring of 2022. And now we will move on to our first, but now let's get on to the symposium. And I hope you find that it is truly out of this world. Alex Sodala will be introducing our keynote speaker.
Thank you, Ryan. Hello, and welcome to the third annual Owls in Space Symposium. My name is Alex Sodala, and I am very proud to introduce our keynote speaker for this event, NASA Johnson Space Center Deputy Director, Vanessa Wyche. As the Deputy Director, Vanessa has provided executive leadership to nearly 12,000 civil service and contractor employees in Houston, Texas, as well as the White Sands Test Facility in New Mexico. She oversees a broad range of human spaceflight activities, including NASA's astronauts, mission control, development, and operation of human spacecraft in low Earth orbit, and plans for human missions to the Moon and Mars. A native of South Carolina, Vanessa earned a Bachelor's of Science in Engineering and a Master's of Science in Bioengineering from Clemson University. Vanessa also completed an executive leadership program at the University of North Carolina's Business School and is a current International Women's Forum Fellow. Before joining Johnson Space Center in 1989, she worked for the Food and Drug Administration in Washington, D.C. Over the span of her career with NASA, she has held several other distinguished leadership positions, particularly Assistant Director of Johnson Space Center, Flight Manager of several missions of the Retired Space Shuttle Program, Executive Officer in the Office of the NASA Administrator, and led center-level technical and program organizations. A strong supporter of innovation and inclusion at NASA, Vanessa serves as a member of the Johnson Space Center Innovation and Inclusion Council, advocates mentoring, and is a passionate promoter of science, technology, engineering, and math. If you have any questions for Vanessa, please enter them in the chat to be answered in the Q&A portion of this presentation. Now, please help me give a warm Rice welcome to our keynote speaker, Vanessa Wyche. Vanessa, on to you.
Hi, Alex, and good afternoon, everyone. Thank you so much for inviting me to be a part of this event. I actually had the pleasure of being maybe there for the first one and enjoyed it very much. And I really am very I'm proud of what you guys are doing. I mean, you know, having a CubeSat is phenomenal. And so I'm looking forward to putting my name on it so that I get to go into space with you guys as well. So I'm going to give you a discussion about what's going on currently at NASA, especially at the Johnson Space Center. That are going on in the science area as well. Let's see. So guys, am I going to be in charge of the slides? I think, are you?
We can give you control if you want, Vanessa.
No, it's fine.
Okay. I
okay.
will just say next slide and I will move on.
Okay, great. All right, so before I go further into the presentation, I have just a very short video that will highlight a lot of the things that are going on in human exploration, especially with regards to the Artemis program. So if we could start with that, it's very short, and then I will come right back as soon as it ends.
We're going to the moon to explore, and we're going to the moon for scientific discovery.
Our destiny is always to go and see what's further and what's next.
The moon is a stepping stone, and the moon is a place we need to learn how to live so that we can continue to go beyond.
We are focused. We are focused on all that lies before us. Only together will we bring to life this global ambition of returning to the moon. And while our work is far from finished, we've never been closer to seeing a new generation step beyond our home planet. We are building on the achievements of those who came before. The giants who conquered gravity and raised a banner in the heavens, they beckon us to go farther, to the moon and on to Mars, to seek a deeper understanding of our universe and bring all that we learn home. 2020 was a year of unpredictable hardships, and yet, step by step, we resolved to press forward toward this grand vision. The daily efforts of thousands of suppliers from all across this country and around the world fed into stunning milestones and laid the groundwork for history.
Launch team, go.
Artemis has been woven into our culture. It has fostered collaboration across the aisles and across the ponds. It has grown beyond plans and preparations to include hardware and software. And now, it has a heartbeat. You can feel the momentum. It is undeniable. We are going. And together, we will see Artemis light the way.
Our mission to the moon is no longer some far-fetched dream. This is reality. We are going.
This is the next step in evolution.
They're not just PowerPoint slides. They're actually metals being bent, shaped, formed to build the things that we're going to use.
This is real. This is going to happen. We're going.
We are going to the moon to learn how to live on other planets for the benefit of all.
Let's go.
Awesome. So a lot of what it takes to do the Artemis program is happening in Clear Lake at the Johnson Space Center, as well as at our test facility at White Sands in New Mexico. At the Johnson Space Center, you can go to the next chart. You know, we're the home of astronauts, and so we have a lot of planning that we're doing there with regards to the Artemis mission. I want to share that Rice alumni are a big part of that. And right now we have 83 alumni, 6 that are a part of senior staff. And actually we've had 14 astronauts across the ages that have been a part of NASA's mission. Next chart. I'm going to start first talking about the International Space Station, because we can't just jump straight to Artemis, right? Today, we have the International Space Station, which is our platform that is in what we call low Earth orbit. So it orbits the Earth at about 200, 250 nautical miles above Earth. And it is a laboratory. It's where we are able to do scientific research, technological research. We also do research on our astronauts so that we can study the effects of long duration exploration, because that's what it's going to take for us to go to the moon and beyond. But we're also learning what technologies we can test out on the space station. Okay, I'm not sure if that's if my Wi-Fi is cutting out or not, but these are the current astronauts that are on board the International Space Station. And second from the right is Shannon Walker, and she's a Rice graduate, and she is on board the space station as a part of SpaceX Crew 1. And the other crew members that are there, we had 3 that were launched by the Russians, and then 4 that went up on SpaceX. Next chart.
You should be able to see the Gulf of Mexico here in the shot just momentarily, as we're now just about 20 meters off the ocean.
So the video that's playing, this is from the first crewed mission, DM2, which landed in the Gulf of Mexico, and what you're seeing is the actual landing, and then the recovery ships went out and picked up Bob and Doug and brought them back. So as you guys are aware, after the shuttle program, there was a very long period of time before we were able to launch again from America. And so these two were the first, and we're just super glad now that we have the capability again to launch our astronauts from here. We do and will continue to have some that will be launched by the Russians, as the International Space Station is just that, it's international. So we do have the capability now of launching from both locations. Next chart. And then the second crewed flight was Crew 1, and this was actually their launch, and they're on board. Side the International Space Station. Let's see, next chart. Then the next step will be Crew 2, and so these astronauts are almost ready to go. They're in their final preparations, and right now the plan is that Crew 1, we're planning a handover between these crew members, and then Crew 2, so they'll launch, and then Crew 1 will return. And their launch is currently planned for mid next month, April 22nd. Next chart. And Boeing is continuing to develop their commercial spacecraft, and we have astronauts that are training for that mission as well. They're planning a orbital flight test, a second orbital flight test that's going to happen very soon, sometime this spring. And after that test is completed, then we'll have their first crewed flight test. Next slide. And that takes us to, what it takes to be able to support all of these spacecraft and all of the astronauts that are in training. Our Mission Control Center in Houston, we are there supporting the International Space Station. We coordinate with SpaceX for all of their launches, and as well as entries. And for Boeing, we will be doing operations for the Boeing spacecraft as well, and also preparing for Artemis. And at Ellington Field, which was on the earlier photo, we do have spacecraft so that our astronauts can do high intensity training, as well as the neutral buoyancy laboratory when the astronauts go outside of the vehicles to do what we call extravehicular activity. Facility that right now is very full. This was an earlier photo where it has, we also have a Starliner for training. We have an Orion spacecraft for training, as well as now the human landing systems that are being developed. We have those mock-ups there as well. Next chart. And what does it take to be able to do all that? Well, we have to have human health and performance. And so we, on the ground, we have ground analogs that we do long duration performance training, exams, etc., as well as we are building exercise equipment, other crew and health equipment, so that we can make sure that our astronauts are healthy when they're on board the International Space Station and as they develop now going forward to the moon. Next chart. And so we're going to talk a little bit about Artemis. So Artemis is the program that we've been working on. I know Jim Bridenstine, when he was there year before last, and I know Mark Geyer had given an update, but we are very much still pressing towards Artemis and having the first woman and the next man to go to the lunar surface. And we're doing it sustainably. And from there, we will go on to Mars. Next slide. And as Apollo changed the world, we're looking at Artemis to do the same. And this time it's to do it with a sustainable vision. Next slide. So what is as well as building up towards having a gateway, which will be a small spacecraft that will be in lunar orbit. And the gateway will have the ability for us to have the human landing system dock at the gateway to go to the surface. And on the surface is where there'll be operations of scientific discovery, exploration discovery, towards having a Artemis base camp. Now, base camp is not going to be a permanently tended people there all the time. It will be crew tended as well as the vision for the gateway. Next chart. And the people, which is near and dear to all of our hearts, making sure that everything is safe for them to be able to go. Artemis cadre, and these are those crew members, some that are on orbit today. You see some familiar faces, and then additional ones that are training and that have flown, and some are already in training for other missions as well. Next chart. And so I'm not going to read every word on this chart, but this is to show you that there's a buildup. As I mentioned, we are starting first with robotic missions on the surface, and there are companies that are vying for that right now. We actually have one, Intuitive Machines, that is going to be launching this year to a robotic mission to the surface, as well as another company, Astrobotics, and the company that you guys mentioned, Firefly. They also are part of the campaign as well. Then after that, Artemis 1, we're planning to do an uncrewed launch that is well underway. As you saw in the photos in the video, the core stage is finishing up testing. The Orion spacecraft is already at Kennedy. It's ready. It's being fueled and processed. And now it's time to integrate the two of them together and get ready to do an uncrewed launch to the moon. And it's going to be very exciting. And then after that, Artemis 2 will be the first time that we put humans on board, and we'll do a mission that does a lunar flyby. And then the gateway will be launched. We'll have elements of it going up. And then in Artemis 3, over to the right-hand side, will be a launch of astronauts to. Right now, the plan is for it to go to Orion and mate up with the landing system. And I'll talk a little bit more about maybe potential adjustments in the plan. But all of these elements, I want you to know, are in development, and not just by NASA as a government entity, but by commercial companies that have their part and their responsibilities as part of this plan, as well as the internationals. So this is a truly commercial NASA international venture. Next chart. And this is just continuing to show you the buildup of usage of the gateway so that it will be there to be a platform that, as again, would be human tended. Astronauts would go, maybe spend about they'll be able to collect samples, maybe do some processing. And we're also looking at a lunar terrain vehicle that will allow them to be able to go further than just their lunar base. In addition, we're then going to be building up eventually to having a pressurized rover that would allow even further and further ventures away from the home base, and then a surface habitat. So all of this, of course, is preparing us for going to Mars. And that's why Mars is in the right-hand corner over there. It's to say that this is learning as a proving ground, developing what does it take to sustainably have a mission that allows us to learn how to Next chart. So as I mentioned, I'm going to just flip through these right quick. It's just to let you know that Orion and SLS are very much, this is real hardware. These are not photos that is in development, being tested, and being ready and prepared to go. Next chart. And then the Gateway, likewise, as I mentioned, this is a international adventure also. The U.S. is right now working, developing a power and propulsion element that will carry out a small habitat called the Halo, and that's being built by Northrop Grumman, as that will go to a orbit that's very stable orbit, and there we will connect with, let's see, the Canadians are going to provide a robotic arm, the Europeans are building a habitat in conjunction with JAXA, with the Japanese. They're going to be providing a part of the life support system, as well as the avionics. And on the very far end is the Orion spacecraft that you saw in the other photo. And so this would be a location where the human landing system on board the Orion and meet up with the Gateway, and then they could transfer over to the human landing system. The intent also with the international habitat would be to have technologies that will be tested out as well. So this is a rendition of what the human landing system would be, and this would be the final element of the transportation system for the immediate initial part of the campaign of going directly to the surface and then returning back to the Gateway. Next chart. And this is a photo of what proposed for the Lunar Terrain Vehicle, which would allow greater locations across the lunar surface. Next chart. And this is also a rendition of what the Artemis base camp could look like. Again, the intent is this would not be humans staying permanently. They would go do operations, exploration, scientific discovery, and then the intent would be to go for longer and longer periods of time. So the initial stage would maybe be short stays for 3 or 4, 6 days or so, building up to a capability of maybe staying for 2 weeks, even up to a month at a time. Next chart. And to do that, you know, at the Johnson Space Center, one of our responsibilities as having the astronauts is to make sure that we have all of the equipment that they need to do exploration. And the current suits, when the crew members go outside of the space station today to do their EVAs, those suits are about 40 years old, and the technology has been phenomenal for us to continue to use them. However, as with anything, the life of it will eventually run out. And so for us, we are developing a new suit, one that we're going to do a demonstration using the International Space Station, which is there close to home. So we can go do a test, and if we need to make tweaks to it, we can bring it back and make mods. It's the beauty of doing it on the ISS, and then develop it so that it's ready for us to take it to the surface. Next chart. And right now, the materials that have been recovered from Apollo, we also have some other materials that we house at the Johnson Space Center, but we will continue to do curation of samples that are being returned from other bodies. And the picture in the left corner there is the picture on the Oval Office. The current president requested to have an Apollo sample in his office, and we were honored to make sure that he had that. So it's the bottom shelf. It's a display there, and so we will also, I know that a lot of people, thank you so much. A lot of people are excited about the Perseverance launch that just happened, going to Mars. And I do want you guys to know that for the Mars return mission, which is going to happen probably another 6 years from now, when that mission goes, when those samples come back from Mars, those samples will be curated at the Johnson Space Center. So we're super excited about the Perseverance launch, and we're looking forward to actually having real Martian origins, and we study those, but to have pure Martian samples come back, we're very excited about that. Next chart. And this is just to share more. I'm very excited that you guys are part of the CubeSat program. And we also want to encourage you to apply for some of the Artemis challenges. We have a Micro-G next, where it's a challenge where undergraduate students can design and build and test hardware. And this test is actually done at the Neutral Buoyancy Lab there at the Johnson Space Center. And so we would like for you to apply for that, as well as competitions that are being put on at Kennedy Space Center, looking at engineering life cycle processes for developments as well. So both of those are ongoing competitions. If you go to the nasa.gov STEM Artemis, you can find next chart. I guess it's loading. And we also have a NASA Suits Challenge, which is another student challenge where you get to participate in the design of the spacesuit informatics. And so that competition, again, this particular one is a student who is looking at augmented reality and how that it's a part of the actual spacesuit itself. And then there's a Big Ideas Challenge. That one is another university challenge, and we would love for you guys to participate in that one. That one is looking at concepts for Moon to Mars. This particular team, they won based on their Mars base concepts for modules. Next chart for habitats. And then there's another student challenge. That the one on the left is a rockets challenge that's ran by the Marshall Space Flight Center, where they design rockets, and so they have a student challenge. And then there's another one on exploration rover challenge that they do there as well. So those are just some opportunities that we want to make sure that you guys are aware of. Next chart. And then I just want to make sure that you're aware that we want you to join us and become an intern. And so fall intern applications are opening on July 9th. We just closed applications for the spring, and that was just yesterday. And I'm going to end there so that, because I see we're running a little long, because maybe be able to take a couple of questions if there were any. So.
Okay, thank you, Vanessa. We all appreciate that overview of kind of what's going on at NASA and what the future looks like. So our first question is, what are the top 5 attributes you look for in a successful astronaut candidate? I'm sure you get asked that all the time.
Yeah, well, you know, it's probably the same top 5 attributes that we look for in all of our employees. You know, you're looking for people that are the best in their field, whatever that is. Of course, as you know, for astronauts, we have doctors, we have scientists, we have engineers, we have pilots. So it just depends on what the field is that they're in. But we're looking for the best and the brightest. And we're looking for people that can work in teams, when you are on board the International Space Station for 6 months, or if you're going to Mars on a long duration flight that could be 2 or over 2 years long, you need to have somebody that's able to work well with others. And we're looking for people that are just innovative. Yeah, need to be able to handle stress, have to be able to come up with creative solutions to challenges.
Speaking of innovation, we had a question about what are the innovations the space industry is currently developing to achieve sustainable infrastructure on the moon. Can you talk about that at all?
Yeah, some of the things that are being done for us to be able to sustain on the moon, right? We're looking at what we call ISRU, which is Institute Resource Utilization. How do you take things out of the regolith that you can use maybe for rocket fuel? That's one thing that we're looking at. How can you make sure that you have sufficient power? So there's different power technologies that are being looked at, whether they be nuclear or solar electric, but different technologies in those areas.
Okay. Next question. As spaceflight becomes more and more privatized, how do you feel NASA's role will change in the coming decades to adapt?
Well, I mean, spaceflight is already changing, and our role has been changing. We welcome additional commercial partners because actually that helps us be able to expand. As others come online with their capabilities, then that allows us to expand our reach. And so we expect that we'll continue to do exploration, which is what we want to be able to do, but it allows us to go further when we all are working together.
Okay, thank you. Next question. How's the need for a second green run hot fire impacting the timeline for the Artemis project as a whole?
So as a whole, it's of course taking a little more time, so that adds to the schedule. But for us, we can't actually launch right until we're ready to go, and it has to be safe. So it may it may impact the schedule by a month or so, but that's not going to impact the overall mission flow. Artemis 1, as I said, is an uncrewed mission. And then we'll have time to be able to move towards Artemis 2, which is our crewed mission. So not significantly.
Okay. And then finally, for our last question of the day. So what's after Mars? You know, this panel is about what's the future of space exploration going to look like in the coming decades and century. Does NASA have any plans written on a whiteboard somewhere after that?
Well, actually, what we're interested in is where does everybody else for others to be able to give their input on where do we want to go. Okay. So it's not just up to NASA. We're looking and working with scientists and industry and others to give their thoughts as well.
Okay. Well, thank you very much. Unfortunately, we're out of time today for our Q&A portion. Thank you to everyone who submitted questions. On behalf of SEDS Rice, thank you again, Vanessa, for spending part of your Saturday with us. And let's give Vanessa a round of applause for her words of wisdom.
Awesome. You guys keep doing what you're doing, and look forward, as I said, to seeing you in the internship program and then seeing you as professionals in the future.
Thank you. So now we're going to have a short 10-minute intermission before Justin Lee moderates our first panel, Space Education, Awareness, and Inspiring the Next Generation. In the interim, please enjoy this presentation from the Rice Eclipse Rocketry Club from Jeffrey Michael.
Thank you, Alex, and good afternoon, everyone, and thank you for attending the 2021 Owls in Space Symposium. My name is Jeffrey Michel, and I am the president of the Rice Eclipse rocketry team. We are Rice University's competition rocketry team. In this interlude between the keynote speaker and the next panel, I'm going to give a brief overview of the work that we do here at Rice to get students involved in aerospace design projects. Next slide, please. So we are Rice Eclipse. We are the largest project-based engineering club here at Rice University. We have over 50 student members who come from diverse majors and backgrounds. We pride ourselves on being an environment where any Rice student can come and learn the fundamentals of rocketry and engineering, regardless of their background and experience level. Next slide. So what we do, in short, we build rockets. Every year we compete in the Intercollegiate Spaceport America Cup rocketry competition. It is a global competition with over 100 teams from across the world, and we compete against the very best from around the world with the very best of our Rice students. We build rockets, but we also build a lot of the ancillary hardware that involves in launching rockets as well. So beyond the rocket itself, we build rocket engines from scratch, as well as all the electronics, hardware, and software that go into controlling an engine and controlling a rocket in flight, as well as scientific payloads for all of our rockets. Part of the competition is actually launching a science payload on the rocket. So we actually get to do science on our flights as well in collaboration with Rice professors, which we're very, very excited about. Beyond these competition rockets, we also run a high-powered rocketry certification program where any Rice University student can come to Rice Eclipse and build a rocket and get certified in high-powered rocketry with our partners here at the Houston chapter of the EEE Rocketry Association. That's sort of the first step for many Rice students to get involved in aerospace engineering or just design of space systems, and it's a program that we're very proud of. And then beyond rocketry work, we also do STEM outreach here at Rice University and with different organizations outside of the university as well. Next slide. So I'll go into now just a quick overview of the the rocket engine development work that we do here on Eclipse. So our first engine is the Luna engine. It is a smaller test bed engine, about produces 50 pounds of thrust. We use it as a test bed for propulsion, for different propulsion technologies, as well as procedures that we then go on to apply to our larger engines. After developing Luna, we worked on the Titan engine, which is a ground prototype engine that's much larger. It's about 800 pounds of thrust. We successfully completed a hot fire test of that engine back in 2019. You can see a picture of that right in the middle there. And then since Titan, we've moved on to a new engine called Titan II, which takes the lessons learned from Titan to build a slightly larger engine that is also optimized for flight. So this engine will actually be used in a competition of rocket flown by Rice Eclipse in 2022, which I'll touch on in a second. The engine is currently being manufactured as we speak. And it will start its test campaign at the end of the semester, which is something that we're very much looking forward to. Next slide, please. And here's just an overview of how our competition rockets have developed as well. The past 3 years, we've competed in the 10,000-foot solid motor category of the Spaceport America Cup with our Noctua 1, 2, and 3 rockets. You can see pictures of them over there on the left. This year, we're building a rocket named Athena after the Athenian owls at Rice University's seal. It is the largest, fastest, and highest flying vehicle that the team has ever built. It will fly to 30,000 feet using a commercial solid motor, and it will also be the first vehicle built by Rice students to break the sound barrier, which we're very excited about. And this is all building towards an even larger rocket in 2022 named Archimedes after Merlin's owl. You might be noticing a theme there with the names. And that will be propelled using our Titan II hybrid motor. So that will be the first rocket built by Rice students where from the tip of the nose cone down to the exit of the nozzle is completely designed by students here at Rice. Next slide. And the ultimate goal of all of our work here at Rice Eclipse is to prepare students to get involved in the space industry. And as you can see, this Rice Eclipse is a launch pad for many Rice students to go into the space industry after they graduate and while they're here at the university as well. Eclipse alumni on both internships and full-time positions you can find them at different NASA centers, including Johnson Space Center here in Houston, as well as the Jet Propulsion Laboratory out in California. as well as most major aerospace companies across the country, as well as several aerospace PhD programs. And we're very proud to do our part to launch the Artemis generation here at Rice. Next slide. I also just want to quickly thank our sponsors for all the support that they've given us over the past years, both within Rice University and our corporate sponsors. We couldn't provide these experiences to Rice students without their support. I also wanted to thank them. Next slide. So that was a quick overview of the team. We have a booth over at the career fair a little bit later on in the symposium. So if you are a student interested in getting involved with Rice Eclipse, or you want to just learn more about our projects or what we do or how you can support us, please stop by there as well. I'm happy to answer any of your questions. And with that, thank you all for listening. And now we will continue with the Space Education and Awareness panel of the symposium after a short video.
God willing, as we shall return.
You probably dreamed of this.
Liftoff on Apollo 11.
You probably replayed this moment 1,000 times. You probably imagined the awe-inspiring, indescribable rush of the ride. You probably celebrated the miraculous, cheered the momentous, and mourned the shocking. You probably still dream of what could be. We did. We do. And while many thought we were through, no. We've been learning, we've been building, we've been training. And now, it's time. Because the next frontier is not just for the next generation. It's for this generation. It's for me, and it's for you. For everything we still dream about. We go as Artemis.
Hi, everyone. We will now be beginning the Space Education, Awareness, and Inspiring the Next Generation panel. My name is Justin Lee, and I am a freshman studying mechanical engineering at Rice University, and I will be the moderator for our first panel. So let me just make sure everyone is here. Okay. Yes. Hi. Looks like everyone's here. I'd like to start off by asking all of our panelists to introduce themselves, starting with Shelli Brunswick. Please introduce yourself.
Well, good afternoon, and thank you so much for inviting me to join you today. I also want to thank your sponsors and congratulations on putting together a fantastic event. You all deserve a round of applause for that. I'm Shelli Brunswick. I'm the Chief Operating Officer at the Space Foundation, and many individuals know the Space Foundation. We are a U.S. nonprofit that does business internationally, and we look at three main areas we focus on, and that's global alliances. Again, how do we work with the global community? We have our Center for Innovation and Education. That's all about creating that space ecosystem with workforce development and economic opportunity. And then we have our Symposium 365, which many people are familiar with, our annual symposium where we bring people together, but we have also during COVID gone digitally and now have it running year round. So I'm honored to join you all. I am a UN mentor for Space for Women, as well as a Women Tech Network founding member and a former Air Force officer, retired after over 29 years in the military doing space acquisitions. So I'm honored to join you all today, and I look forward to a really robust and exciting discussion.
Thank you for that introduction. Can Harper Cheyenne go next?
Hi, Justin, and hi, everyone tuning in. I am Harper Cheyenne. I'm the Vice Chair of SEDS-USA, Students for the Exploration and Development of Space, USA. If you're hopping on this call, my guess is that you already are part of a chapter of SEDS, but if not, for any reason, feel free to reach out to us. We're always having new students and chapters join our organization. Outside of being the vice chair, I'm actually a marketing, finance, and physics major at the University of Central Florida. I started out in business, but added physics because I believed that I couldn't be a part of the aerospace industry if I was part of business alone. So I am a huge proponent for having everyone in on this industry and working on projects together. So very excited to have this discussion. Thank you, everyone.
Thank you. Kaci Heins, can you also go next?
Hi, everyone. My name is Kaci Heins, and I'm the Space Center University Director at Space Center Houston. We're so excited to be here. We've been working with the Owls in Space the last couple of years, having a booth there. We've even had a Rice University intern in 2019 who's now working at Kennedy in the Artemis program. So it's really exciting to see that. And, you know, Space Center Houston, this is what we do. We educate the general public and kids to inspire that next generation of explorers. We have daytime, evening, overnight programs, you name it. We're here to inspire. So thank you for having me on this panel.
Thank you. And last but not least, of course, Dr. Kirsten Siebach, can you please introduce yourself?
Yeah, thanks for having me. I'm Kirsten Siebach. I'm an assistant professor at Rice University, and I am a professor in the Earth, Environmental, and Planetary Sciences Department. I sometimes call myself a Martian geologist. I actually did all my training working with Mars data. So I've been working with surface missions on Mars for the past 10 or actually more like 12 years now. I worked on about 4 of the last surface rover missions. And now I'm really excited to be working on the Perseverance mission. And then as a professor, of course, working towards sharing that excitement and sharing our discoveries with the next generation. So really excited to be part of this panel. Thanks.
Thank you. Before we begin, I would like to remind our audience that questions should be submitted through the Q&A icon instead of the chat bar, and we will be answering these questions towards the end of the panel. So for our first question, I'd like to start us off by asking what exactly is space education? And why is it so important to society that young people today are exposed to space?
I'll just jump in. This is Shelli. We like to think of it not as space education, but space-inspired education. And we really look at it as formal education in the classroom. Because many times when we look at after-school activities, that may already eliminate everyone in society participating in those activities. Many individuals may find rocket clubs or space astronomy clubs exciting, but they're already motivated to be in space. And so when we make it an after-school activity, we can eliminate part of our society from participating in space careers. When we include it, full immersion in the day-to-day curriculum for students, we're allowing all students to see that there are a variety of careers. And I heard some folks, Harper, I think you highlighted, you know, we need everybody in the space industry now. It was a time where we really needed STEM professionals and rocket scientists and astronauts, but now we need everyone, non-STEM, technical individuals, artists, entrepreneurs, business leaders, and STEM professionals. And so when we bring space-inspired curriculum into the classroom, we allow groups that have been underserved that have not come into the industry, underrepresented groups, to find a place in this growing space ecosystem.
And I'll piggyback on Shelli's statements there, because that's what Space Center Houston does. That's what, you know, we are the official visitor center for NASA Johnson Space Center, and we're here to inspire the general public. And we were hitting 1.2 million visitors a year just in the general public, and the education programs are critical to inspire that next generation. And along with that, we have our educator program. We just wrapped up our Space Exploration Educator Conference, because that's what's going to help us continue to inspire those kids outside of our walls is having those teachers that are inspired and they see the benefit of science, technology, engineering, and math and can integrate it into their classrooms and get them on the STEM pathway and into the workforce.
I can follow up. I love that, what Shelli said about, space-inspired education and really using it as an inspiration tool. I think that is one of the major drivers and major perks of integrating space into any education, right? And we saw that very clearly with the Apollo missions. I mean, those inspired a full next generation of people who went into science, technology, engineering, mathematics, right? All of these different fields. They may not have ended up working on space directly, but that kind of inspiration is really part of our purpose and also, part of the big benefit. And that's not the only benefit, of course. The innovations that we do for space end up benefiting us in society in a lot of ways. But I do see that inspiration as a huge benefit that we can use to inspire a lot of different types of curriculums.
The really unique concept of space education at this time in our timeline of technology, if you will, is that there are a lot of space educators on Instagram, on Facebook, on YouTube, on Twitter. It's so accessible. So not only can students, see the Perseverance rover land on Mars on their TV or on YouTube, for example, but now they can hop on Instagram and see that, somebody's performing an experiment that they can watch in a bite-sized piece and then learn from that. So it's really amazing.
Yeah, if anyone has any more comments relating to this discussion, then feel free to hop in. But I thought it was interesting how, Kirsten, you talked about how a lot of the inventions we have today are kind of inspired and created by the process of overcoming the challenge of getting to the moon. I believe many of our inventions today are here because we took that challenge on and overcame it.
I might piggyback onto that. I mean, I think it's really important with space education is sharing the spinoffs. When we are living and working or trying to live and work in one of the harshest environments that we know of, all the amazing technology that is developed off the Earth for the Earth. And most people have no idea, like the infrared thermometer, to get your temperature in your ear was developed based on how it was used on a telescope. And so being able to share that with the general public, probably your whole household has things in every room that was developed based off its purpose in space, and now it helps us every day. I think raising that awareness helps them make connections and also sees the benefit and support if it goes to something like with your legislators, making sure that space remains important, not just for kids in the classroom and for you all in the university setting, but it's important for everyone to be aware that space is really wicked cool, but it's also really, really important for all of us on Spaceship Earth.
And I'd like to just jump on that as well. That's one of the areas the Space Foundation is very focused on. For our Center for Innovation and Education, the whole innovation piece is about that technology piece, unlocking space technology. When people think about space technology, yes, they're thinking about Elon Musk, but they may not be thinking about water purification or formulated food or mammogram technology. And so what I'd like to share, first of all, we all have these little cell phones that you can't see in my screensaver, but there's 3 different types of space technology in your cell phone. The entire financial system is running on space technology. Our food supply chain is now running on space technology. Cordless power tools, how we're planning to get on an airplane. Don't you really want your pilot to have the best weather so that they can avoid some turbulence? And that's all coming off our space technology. So as people think about why are we going to the moon and Mars, I want them to also understand how it's going to come back to Earth, that we're going to unlock this innovation and technology and create a whole new entrepreneurial group that are gonna, and the great thing about entrepreneurialism is entrepreneurs create a job for themselves and others. So Elon Musk is a great role model, but so is every individual that wants to go to the NASA Technology Transfer Office and look at all the patents that are waiting there right now that could be applied and brought to market, and you can get a grant to do some of your basic research and marketing activities. So again, it's a whole ecosystem of going to Mars, but then how do we on Earth benefit from that? And we all benefit from it every day.
And really, those are just so incredibly linked, right? We talk about the inspiration of space education, or the inspiration that we get from space education, or from looking at these images of Mars and the moon, or thinking about, you know, what would we do to have a spaceship go to Mars, and what would we need to build that colony, right? We think about the inspiration of that, and it's completely linked with the innovation. The innovation is just driven by facing these kind of questions that you may not have realized you had because you're sitting on Earth and you're content, you've got an atmosphere and everything else, right? But then when you push yourself to think, well, how would I survive in these strange conditions? You start to think about new technology or new ideas that then drive all of these innovations. And so it's that new challenge, that big question, that big picture that space kind of inspires and is that drives these kind of innovations and inspiration. And so space education is really just broadly, you know, using that big picture motivation to push us to think bigger.
So yeah, we can see that there are so many consequences from pursuing and advocating for space education. But I'd like to ask the next question, which is, what are we doing now to educate students and the general public about developments in space?
Well, how about I start with the big picture, and then I'll let our other experts jump in. Let's start with the big picture of what is this space economy and what is it defined by? So right now, the Space Foundation has identified that the 2019 space economy was $424 billion. And it's projected, depending who you listen to, whether it's UBS or Bank of America or Morgan Stanley, that is going to triple by 2030. And you're then looking at 3 trillion or more space economy by 2040. So you're looking at exponential growth in this space ecosystem. And what again is that space ecosystem? It is the launch and space side of it, but it's also the data analytics and artificial intelligence and robotics and advanced manufacturing, cybersecurity. So it's really a broad area. So when you're thinking about going to space and that space ecosystem, think about that growth and that workforce development and economic opportunity, because part of the role of Rice University and every other professional organization is, as we see the economy growing with that global space ecosystem of $3 trillion, how are we now going to create the workforce to fill those jobs? And the other great part is, in the US, in some other ecosystems, the global space economy is 80% of that budget. So when you think in the US, you're really looking at that entrepreneurial piece again, going to work for a company versus a government and everything. And I love NASA, and NASA's great, but for people that are, you know, 8th graders right now tuning in, your future space job might not be working for the government. It could be working for an awesome company that launches a brand new technology that you may not think about. And just to put this in a concrete term, when you think about GPS, we all use GPS every day now. You can't go to an ATM machine without using GPS. Since 1983, GPS has unlocked approximately $1.3 trillion in economic development in the US alone. That's not even including the entire world using it. So as you're thinking about what is that economy, what are those innovations we're going to unlock, that exponential growth, it's all tied to this technology that we're unleashing right now as we're thinking about going to the moon and Mars.
I think regarding the general public, a lot of our space education comes from news articles and blurbs that you see on TV. So just a comment here that I've thought about throughout the week. We just had Starship that had a successful test, but there were several news outlets that I watched right after the Starship exploded, after it had landed just fine, but they reported that it was a fail, or they implied that it was a failure. And so I think, when we talk about how the general public receives their information, space education, when you have more reporters and more people that disperse this information that better understand it, they also allow the public then to better understand what happened, because it certainly was not a failure of a test, but the implication was there. And I know the headlines that I saw were Starship explodes, but they didn't say that it successfully landed. And so, that sort of topic can be broadened to include NASA, Blue Origin, like any other company, right? But it's just making sure that everyone kind of knows what's going on, and from a responsible standpoint, so that we can then invest and know more about these companies and what they actually accomplished.
So I'll kind of touch on how, educating students, in that I was a formal classroom teacher in middle school science for 11 years, and I've been at Space Center Houston developing education programs that reach tens of thousands of kids every year. What we're doing is we just got to keep inviting people into our science and technology centers across the country, get into museums, get that exposure to after school programs, like Space Foundation as well. They have the teacher liaison program, which, it starts in the classroom. And so that's where, you get the teachers getting their field trip set up, or their extra activities, or overnights, or things like that. But also inspiring the teacher at their core. That's what happened to me, because I didn't like space going through college and stuff. And then I got inspired, and now here I am. I've got Lego rockets on my table. So it starts with the teacher, it starts with the public. It's creating those inspirational experiences or moments that make them go, wow, I didn't know that. I want to know more. And, with the Space Foundation, and Space Center Houston has our exploration conference for educators, just getting them inspired to get to all those tens of thousands, hundreds of thousands of kids, because they're going to get excited, they're going to get passionate, they're seeing what SpaceX is doing, because all of that is so much more in the public, and they can say, I can be a part of that, I can be a part of the mission. And yes, the astronaut is always kind of front and center, and the scientists, engineers, but the cool thing is that they may not know, you can be a part of the mission in so many ways: legal, medical, accounting, getting into PR, creating those awesome backgrounds. They need someone in audio and visual, and you have no idea. And that's what we got to get them. We got to make them aware. And it starts, just by inviting people in, talking about it, sharing it, and we can change the world, and we can even change outside the world, hopefully, eventually.
Yeah, that's great. And I waited for you to talk, because actually, for me, I'm working on the mission, trying to operate the rover. Very grateful for the amazing engineers, because we have these beautiful pictures that really help with any kind of space education, right? Mars does a lot of the work for me. But then from my position as a professor, it's kind of working towards helping teach science communication, and for me to try to take advantage of organizations that are out there that put on events like this, right? And the Space Center Houston does those. You guys are doing that with SEDS. That's awesome, because having those events means I can drop in and help share some of the amazing images that we're seeing, and some of the amazing technology that we're developing, and the excitement of it all. Whereas, in my position, I get to teach the people in my classes, but it's harder to reach out to a broad audience unless there are events like this. That said, I also really wanted to highlight, that educating teachers is a really effective pathway towards educating a broader diversity of students. And so I have also, I've tried to put a lot of energy into that, because those K through 12 teachers reach so many students and have such a big influence. And so, yeah, so for me, it's trying to find those little opportunities, trying to find organizations like this that help me share our story, and then helping train my own students and helping train those in science and engineering and geology working on these problems to communicate as well, right? And that's really important no matter what field they go into. But I think scientists in this world really need to be educators. Harper mentioned that the scientists in these programs now have a lot of outlets, so we can tweet or Instagram or Facebook or whatever it is, and we can actually get the word out about what it's like to actually work on these projects. And I hope that helps inspire these next generations. And so, so thanks for putting on these events.
So if anyone has any more points, we can move on to the next question. So the next question is, with the nature of virtual learning in our current pandemic, what do you think education will look like in 50 or 100 years from now?
That's a tough one. The formal classroom teacher and informal, it still needs a lot of evolving. There's a lot that hasn't changed. And so, with the pandemic, I think there is now finally a reason and some shifting to make education more equitable across the board, whether you're on site or virtual. And so it's got a long ways to go. I don't know what the answer is 100%. I'm excited to see where it goes because I think it's been a tough year, but it's also been a year to really focus on change to meet the needs of our students, and to just make sure that we provide the best high quality education across the board, whether you're on site or virtual.
Yeah, I think in some ways it's really expanding our horizons, right? We, as professors, we all transition to online learning, but in some ways that was an advantage. I was able to have students in my 100 level class from Hong Kong this last semester, and so we can now reach larger audiences or reach more diverse audiences in sharing our stories, and we're getting a little bit better at using these different digital technologies. And so hopefully this pushes us towards that vision 15, 50 or 100 years from now that is kind of more equitable and diverse, and people have access to experts who can share all this excitement, so I hope some component of the virtual education will last.
I'll just add on to that. We know that there have been challenges with COVID, especially for but really the underrepresented kids that we see in the space ecosystem, inner city, potentially rural, because they may or may not have the laptops or iPads or internet consistency. So hopefully, as we do see maybe some space solutions with, satellite Wi-Fi and so on, can we help overcome some of those challenges as school progresses 15, 20, 25, 50 years, 100 years from now? Probably we will see education more self-paced, allowing individuals to learn at their own rate, and being very immersive in the information. So whether that's virtual and you go into an immersive area, so there could be a hybrid how school is run, similar to how we see now, once we can overcome some of the challenges of technology. I think what we really need to look at, though, again, is the technology. As the world changes, we are seeing jobs that are going to go away in the next 4 years, 2025, and that is going to continue to accelerate as new technology comes on. So what we really need to do as we're thinking about the workforce of the future is look at a workforce that is going to be lifelong learners. We're going to continue to be reskilled and upskilled as technology changes. I mean, look how much we've all learned in a year. I would have never had a meeting on Zoom a year ago. The first meeting I did on Zoom was in May, and it was like, what am I doing? And now I'm like everybody else. This is our main mode. So we're all going to be lifelong learners. And the other thing are some of the skills that we're going to instill no matter where we are in the timeline of the next 5 to 100 years. And that's teamwork, right? We're all going to have to figure out how do we communicate and work on teams. We all have to be problem solvers, right? What is the problem? What are solutions? How do we think outside the box? Many of us would call that innovative or entrepreneurial now, but it's really problem solving. And then again, what we've learned from COVID is we're going to have to instill resiliency in our children and this future workforce, because we know the world is going to change rapidly with technology and other things. So how do we create a resilient workforce? So I just kind of share with you that I don't know the exact method and mode that education will take, but those are definitely some of the skills we're going to have to look at instilling. And we're all going to be lifelong learners as this technology continues to change and evolve rapidly.
As a current college student, there's been a huge benefit of being able to have more time in my lab to go and like develop a physical rover wheel prototype. So hands-on, I think I've learned more in the last year than ever, arguably. I've soldered, welded, pieced things together, which is really awesome. But there's a devil's advocate side to that, and that's for K-12, consistent access to computers, consistent access to internet use, and certainly space technology is helping move those things along. But there's also another piece to that, I think, looking into the 2030s and 2040s, is that, we're gonna need kids, students that understand how to read emotional cues, to work on a team. And that's something that I constantly think about, if I'm going shopping at this current point in time. I'm like, okay, when we can take our masks off safely, I really want to focus on educating students to use their time and understand how to use technology, of course, but also to work in these teams where you could be facing a hard condition, especially somewhere like space, where if your technology fails, you all of a sudden are thrown into a group scenario of battering down, and we have to figure this out. So certainly thinking about, technology, and, we can save time, I think, in certain aspects, but also just making sure that we don't lose that emotional piece of education that kids grow up gaining.
And I want to piggyback on something Harper just said too, is the experience. Having that is so critical, and more experiential learning opportunities down the road. I'm really hoping to see more of that, because we have so much access to information and we can learn about anything, but until you put it into practice, you're really going to build those skills that are needed for the workforce. And, just working so closely with NASA and folks at NASA, they all say you have to be able to communicate, you have to be able to work on a team, you have to be able to problem solve, but also get through conflict. You're going to have times where you're not going to see eye to eye with someone. So how do you communicate your point of view or what you're trying to get across clearly and have that reciprocated and come to a conclusion that benefits all and benefits your project? So definitely those are skill sets. I know when I was in the classroom, I really tried to touch on, but they've got to have that experience, and I definitely appreciate the virtual components that we've had, but I think we all know we need to get back in the classrooms too at some point to have those interactions 100%.
Yeah, I think that's a great point. I call it emotional intelligence. We know we have a generation that are going, my friend had a 5-year-old who was supposed to start kindergarten this year. So we are having a generation that is missing some of those initial social interactions, and building how do we play nice together in the sandbox. Those are skills we start in primary school and kindergarten, and we carry those through life. So we are going to have to figure out, as Kaci said, how do we overcome this once we come out of COVID to help that generation understand how to play nice in the sandbox as well, and those emotional cues.
And I'll just say my real world example is we're currently driving these Curiosity rover and the Perseverance rover on Mars. And just to put this in a visual, we have one car, there are no roads, and there are about 400 scientists on the team. from different backgrounds. And I don't know, you've probably been on a road trip, right, with 2 people in the car. You can't agree on where to stop. You can't agree on which highway to take, right? So 400 scientists in one car. I mean, these interpersonal skills are actually incredibly critical to the success of these missions.
Yeah, I just like to mention that, like, I totally agree with everything that you guys are saying. Like, schools don't just teach you like how to do maths or like how to learn like how to do like a stoichiometric like calculation. They also teach you like what you can argue is even more important than that, which is like emotional intelligence and how to communicate well with people. So thank you for all of your responses. That was a great discussion. But now we'll be answering questions from the audience as well. So my first question from Arinze Apio Riley. I'm not sure if I pronounced that correctly, but she says, on the topic of variety of careers, where do physiologists, physicians, and other medically related careers fit into growing fields? I'm assuming she means growing fields as in the growing field of space exploration. So.
Well, I know with, oh, go ahead, Kirsten, you can, go ahead.
Oh, I guess I was just going to point out that with the Artemis mission, we're really moving back into an era of human exploration, and humans are more complicated than robots precisely because we have medical needs. And so that is actually like of critical growing importance, is understanding the effects of space, understanding the effects of radiation, and understanding how to best protect people. Medical fields will be really critical for those next steps.
Yeah, and at Johnson Space Center, they're the hub for the human spaceflight aspect. So they have the human health and performance labs there, and so that's a constant. And you're going to have people that are focused on nutrition, diet, exercise, psychological, mental health. They have the human analogs, the hair emissions. So it's a really, really important aspect. And if it's something you're really interested in pursuing, there's lots of opportunities. I would get on the website and kind of see what fields that may appeal to you, and it's something you could pursue.
And I'll just add the part of, we are going to go out there, but you could also look at medical healthcare pharmaceuticals here on Earth. To go out there, we have to slow the aging process. We have to live out in a microgravity environment. We have to live outside, the protection from radiation. And all of that damages the human body. We were not designed to do that. We cannot evolve fast enough to live on Mars. So we're going to have to overcome a lot of these challenges. But that technology is going to help us here on Earth. For instance, we know women develop osteoporosis at a faster rate in the microgravity environment. Men have eye problems. If we can solve those problems to look at moving a colony eventually to Mars or humans to Mars, you're then going to be able to solve those on Earth. If we can bring pharmaceuticals, I mean, look at how quickly the COVID vaccine came online. But if we can bring other pharmaceuticals to market faster, instead of 10 years or 20 years, by using experiments in microgravity environment. So if you want to be in healthcare, absolutely. There's lots of opportunities with NASA and SpaceX and others as to how we're going to go out there and live and play together in the sandbox and all those other parts. But we're also going to have to look at, how do we bring that technology back to Earth? And how, when you think about slowing the aging process, that's all about allowing all of us to have a better quality of life. Some would call that aging with dignity and other things. So for those of you who want to be in the healthcare industry, there's great opportunity for you to look at capturing that space technology and harnessing it and allowing all of us here on Earth to have a better quality of life.
So if anyone has any more questions, any more answers to this question. So far, so good. So I'll ask the second question on the Q&A. It's from Sucheshna Patil. I'm not sure if I pronounced that correctly again, but she says, I am an educator myself, volunteering on being a space educator for kids in remote areas. I'm researching on space analog missions. I would like to know if you have groups for people interested towards analog missions, which can be further practically applied to the Artemis mission. Can we participate? So first, I would like to ask, what exactly is a space analog mission? And then you can answer the question.
So at Johnson Space Center, they have the Human Exploration Research Analog mission. So they have a habitat where they spend, I think right now they're about 30-day missions. But it's really rigorous. It's just as rigorous a process as astronauts. They have to go through multiple interviews. They have to come on site and do a lot of physiological activities to make sure they're candidates. Because when they start a mission, you don't want someone to say, okay, 15 days in, I'm out, I'm done. That just that's not good for the research and it's not good for the mission. So, it's really challenging, and we work closely with them on all of our education programs, which has been phenomenal. And there are other analog studies out there. They have NEMO, which takes place underwater off the coast of Florida. I think Russia has one and Germany has one. So there's a lot of unique ones out there. So you'd have to look into it because they do have requirements for age, health requirements and things like that. But there are ways possibly to get your students involved because sometimes they do outreach. And so that really presents a cool opportunity for the kiddos in your classroom.
Great, thank you. So we have a little bit of time at the end. So I'd like to ask, I think is the most kind of like central question to this, which is, in what ways can we inspire the next generation? So if anyone wants to jump in.
I'll just jump in and say, obviously, to inspire the next generation, we have to provide the variety of role models, especially if we want to bring more underrepresented groups into the space ecosystem. We have to provide those role models. We have to provide mentors and coaching. And so that's why I'm passionate again as a UN Space for Women mentor, Women Tech Network, Space Generation Advisory Council, find a mentor, be a mentor. You can be a mentor as a college student to a high school student. So you can be a mentor at any point and you can have a mentor. So that is really what I encourage, is that we have to provide those role models and those mentors to help inspire that next generation to fill all the jobs that are going to be available in the space ecosystem.
So I feel that it all comes down to an experience. We're all where we're at because something lit a fire in us and a passion that we pursued to be in the careers and what we're doing today because we love it so much. And, as an educator, creating experiences for my students in the classroom was number one because I wanted to inspire them. And it just takes one experience to change a child's life. And it happened to me as a teacher. I did not like space, couldn't stand it. I didn't know because it's so much. Kids ask me, well, what's a black hole? I don't know back then. But it took one experience with space and everything changed in the last 10 years. And here I am working at Space Center Houston, flown on the Vomit Comet a few times. I've flown the student experiments. We launch high altitude weather balloons up to near space. And I've continued that at Space Center Houston. We launch high altitude balloons all the time. We create survival experiences where students get dunked in the helicopter underwater escape trainer and flipped upside down, but they learn about situational awareness. They learn about how astronauts are training for capsule egress. So we're all about creating these amazing experiences to inspire them in that moment and say, you can do this, you can be a part of the mission, so that they can get on the STEM pathway and either end up working for NASA or someone in the space industry, or they're going to go into the workforce to just be a contributing citizen.
Growing up on the Space Coast of Florida was really interesting because there were a lot of these blue collar workers as well as highly educated individuals. And within even those groups, you had, a disparity of women or a disparity of people that looked different, you know, you didn't have the diversity and inclusion that we're pushing now. So I think that it's really important for us to show students that anyone can be a part of this. It doesn't matter like what sort of job you want to do. And we've touched on that throughout this panel, or what you look like, or, you know, what you identify as, or, you know, all of those questions. You can be in space. You can participate in the space era. And then the question changes from, can I do this, to how can I not do this? Because it's accessible, it's right there. It's incredible to think about something like that. So I think it's really important for us to get down to just interacting as humans, being kinder to one another, and showing them that everyone can join in here.
And I think I'll point out one of the things that I've sort of taken on for myself partially, but also I think it's just really important, especially as we're talking to college students, right? It's about sharing your experiences. It's about making, if you are in a STEM field, it is about being one of the communicators in those STEM fields and putting yourself out there as a mentor and believing in the experiences, the things that you know, and being willing to share those with others, whether it is on social media or it is in person or it is in classrooms. I think it's just really important to, we actually, you know, we have diverse people working on these missions. We just need to make sure that they're also out there and sharing what they're learning and what they're doing with the public, with that next generation. And so I put a lot of emphasis on science communication and trying to make sure that we're educating our workforce to also share what they're doing, and realize that that's one of the key skills, both for work and for this inspiration.
Thank you so much. I know that I learned a lot from this discussion. It was really great. I'm kind of sad that we only have 45 minutes for this one, so we kind of have to close it off now, but thank you for this really interesting discussion. I'd like to give you all here, our 4 panelists here, a big thanks for taking the time to join us today. I hope that our audience has gained some value from these discussions from some of the people who are at the forefront of space education and inspiring the next generation. So now SEDS Rice will be giving a presentation about SEDS projects. And after this presentation, Austin Williams will be moderating the Space in the 2030s and 40s panel. Thank you all.
Well, thank you all for joining us. We're now just going to give a short presentation about all the things that SEDS does, minus the OWLSAT, and all of this you can learn about more on the Forager One Symposium platform with all the booths under the presentation tab. There's tons of booths for Rice Eclipse, SEDS Rice, and all of our companies. So I'd like to invite Fenny up to talk a little bit about the Society of Women in Space Exploration.
Thank you, Ryan. Hi, my name is Fenny Pandya, and I'm the president of Space Rice. We were founded in June of 2020, so we're very recent, not even a year old. And our main aim and our mission is to promote women and other diversity groups in the aerospace sector. We want to be able to provide a platform to enable discussions, you know, about career paths and about current trends in the industry and all of that cool stuff. We want to be able to connect our students to the industry professionals and hear their stories. And as we heard on our previous panel, you know, look for those role models. And so we want to achieve all of this by having events like guest lectures. We had a guest lecture by an astronaut trainer last semester. We have one coming up in this month by an astronaut who's a Rice alumna. We want to volunteer at schools and talk to students about how, you know, as to why STEM is so cool and how they can join STEM, and it's open and accessible to everyone. And we also have a booth which will be open pretty soon. So you guys can come out and check us out over there. And if you have any questions or queries, you can answer. You will get answered over there. So yeah, I look forward to seeing you guys. Thank you.
And next, I will just touch on briefly about the Human Exploration Rover Challenge. One of the challenges that Vanessa mentioned earlier on the keynote presentation. This is Rice's first Human Exploration Rover Challenge team. So they're designing a human-powered rover capable of traversing extraterrestrial terrain. So there's obstacles and other items that this rover has to go over. It's completely student built. We even have to redesign the wheel. We cannot use commercial wheels or anything like that. So there's a bunch of incredible things to do with this team. And if you're interested and want more information and want to connect with this team, please check out their booth in the Forager One Symposium platform under the presentations tab. And then next, I'd like to invite Izzy up to talk about the SEDS Lunobotics team, another one of the NASA challenges.
Hello, I'm Isabella Nachev. I'm the lead for the SEDS Lunobotics team. And so the goal of this team is to design and build a robotic mining rover to mine the surface of the moon, and hopefully to compete in the 2022 NASA Lunobotics competition. Hopefully at that point it will be in person and we'll be able to go to Kennedy Space Center in Florida and get to test out our rover in their simulated environment. And so one of the things that I really, really love about this project is that there's a lot of different areas. So there's building and designing the rover, which involves a lot of technical things like mining and engineering and programming. And then there's the other aspects of the competition, like we have to do a presentation, we could create an animation of the rover to get some extra points, we have to do some outreach. So it's a really well-rounded, wonderful project with a great team. So if any part of it interests you, please feel free to join or reach out to me with any questions or comments. We unfortunately don't have a booth, but my email is here on the slide. You're welcome to reach out to me. You can join SEDS and ask questions there. And there is no experience needed. You don't have to feel like you have to have built a robot or a rover or programmed an AI in order to join the team. We're all just here to learn and grow and have a good time.
Thank you very much, Izzy. So if you're interested in that, you can also check out the SEDS Rice booth. So most of our projects actually have booths, including the next major conference we will be hosting will not be the 2022 Owls in Space Symposium. We will actually be hosting the SEDS-USA Space Vision Conference. The theme is Moonshots. It will be held in early November of 2021. And so it'll be held this November, only at Space Center Houston. So if you're interested in learning more about what this conference is, how to get involved in this conference, and how you can meet hundreds of other students from all over the country and hundreds of aerospace professionals from all over the country and learn about the SEDS-USA flagship conference, which reaches thousands of people every year, please check out that booth in the Forager One Symposium. And so next we will have a short video before we start our Space in the 2030s and 2040s panel. Thank you.
Space travel is hard and unforgiving. It's always been and always will be.
It's going to be hard. There's a new chance of death. Going in a little can through deep space, it's a very harsh environment.
We think you can come back, but nothing is certain.
There are all sorts of challenges we'll face on deep space missions. Communication delays, radiation protection, isolation of the crew.
So it is not surprising
that some would have us stay where we are.
There's never going to be zero risk. When you're breaking the bonds of gravity, that's just part of the deal.
And it is one of the great adventures of all time.
Okay, all flight controllers, gonna go for landing. Retro, go. Fido, go. Guide, go.
That challenge is one that we're willing to accept.
Surgeon, go.
Man in his quest for knowledge cannot be deterred.
Space is not just a destination. It changes you forever.
It'll be tough, really tough, but we have the right people for the job.
We have pressed the qualities for success into system after system.
This country of the United States was not built by those who waited and
Past every failure we can dream up.
We have never been more ready to meet the unknown.
Through Artemis, we will once again explore beyond our world.
And we will succeed.
Hello, everyone. My name is Austin Williams. We will now be starting the Space in 2030s and 2040s panel. In this panel, we'll have 5 great pioneers, all of which have unique backgrounds and are really great when it comes to providing their expertise within the field. And to begin off the panel, we will now introduce each of the panelists. As I call out your name, please, panelists, don't be shy to come up and introduce yourself and a little bit of your background. First, I'd like to have Dr. Leroy Chow.
Oh, hello, everyone. Well, it's great to be part of your SEDS meeting today. My name is Leroy Chow, and I was a NASA astronaut from 1990 to 2005. And during that time, I flew 4 missions into space. My first 3 missions were aboard space shuttles, and my 4th flight, I trained with the Russians, launched aboard a Soyuz rocket, and we flew to the ISS, where I served as the commander and NASA science officer during Expedition 10, which was a 6.5-month flight. I've been associated with Rice on a part-time basis since 2012 in the mechanical engineering department and the Engineering College of Engineering. So it's a pleasure to be joining you all today.
Thank you. I'd also like to introduce Dr. Stanley Love.
Hi, everyone. I'm Stan Love. I am a management astronaut at NASA right now, which means I'm not in line to fly anymore, but I'm still working in the astronaut office. Joined up in 1998, flew on the shuttle Atlantis in 2008 for mission STS-122, which put the Columbus laboratory module onto the space station. I worked both robot arms, shuttle and station on that flight, and did a couple of spacewalks. My background is in astronomy and spacecraft engineering, and these days I'm working hard at NASA designing cockpits for future space vehicles such as the Orion and Gateway and lunar landers. And I'm also training to be a Capcom for some of those exploration missions that are coming up. Happy to join you today and looking forward to the discussion.
Thank you. I'd also like to introduce the lovely Miss Tammy Bradford.
Hello, I'm Tammy. I have obviously a different background than the rest of the folks here, but I have 20 years of aerospace experience. My first 10 were spent designing and analyzing space station components, and the last 10 have been on spacesuit development. I currently work for Oceaneering Space Systems, and I am contracted through the JETS contract at NASA on the XEMU project. I am managing the development of several of the life support components on the XEMU, which will be going to the moon. So I'm really excited to be here and just sharing the excitement of space exploration with everybody.
Thank you very much. Next, I'd like to have Dr. Franklin Chang Diaz introduce himself.
Hello, everyone, and Franklin Chang Diaz. I happen to also be an adjunct professor at Rice for a number of years, and so great honor to be a part of your community. I was an astronaut since 1980. I guess I'm the oldest guy here in this team. And flew 7 flights in space. Was an astronaut from 1980 to 2001 and 2005, so 25 years. I've been involved in development of advanced propulsion systems, plasma rockets, electric propulsion, and currently I'm the CEO of Ad Astra Rocket Company here in the Houston area. So continue to be connected with Rice. It's great to be able to communicate with the young people, looking for the next crop of scientists and engineers who are gonna really push humanity deep into space. Looking forward to the discussions.
Thank you. I'd also like to introduce Dr. Robert Bankin.
Hello, Austin. Hello, everyone. Thank you for the opportunity to speak with you all today. I'm excited to be a part of this panel. I've been a NASA astronaut since 2000 and am currently still an active astronaut. I flew a couple of space shuttle missions, primarily associated with assembling the International Space Station, STS-123 and STS-130 on Space Shuttle Endeavour. Following that, I had a couple of ground jobs supporting various programs. I served as NASA's chief astronaut, and then was assigned to fly in the commercial crew program on the SpaceX vehicle. And so was a crew member on board Expedition 63 for a couple of months last summer while we completed the test flight of that SpaceX vehicle before coming home in August of 2020. And now, having finished my post-flight period, I'm starting to support the various commercial LEO activities that are beginning to start here on the NASA side.
All right, awesome. Well, now that everyone is here, I'd like to now begin a few questions. Afterwards, we will open it up to Q&A from the various attendees that are here. So hopefully, things will go well and we can get this show on the road. Now, the first question will be, the Union Pacific Railroad was said to be the technology that opened Western America in the late 1800s. Today, this pioneering spirit is through the aerospace industry. Whether orbit, moon, or other planets, what area do you see humanity colonizing first? Anyone would be free to start?
Well, I'll jump in on colonizing with a statement I think is going to anger everybody on here. So I've had the opportunity to travel to Antarctica a couple of times and spend a couple of field seasons down there hunting for meteorites. And Antarctica, compared to space, is a picnic. It's made out of water. You can breathe the air, you can go for a walk. There are fresh faces at the rarest every 8 months at South Pole. And nobody stays down there very long, and no one has ever moved their family there. So I'm concerned that although colonizing space sounds like a great idea, that when it really comes down to it, people are going to think, if I move my family to the moon, the beach there is no good. And it's hard to get a nectarine. You might want one of those after a while. For comparison, I think the longest anyone has stayed continuously in Antarctica is 5 years. So I think that although we may be able to foresee a way through the technical challenges of colonizing space, when it comes to actually moving there may be some human challenges that are harder to overcome. That devil's advocate statement, I'll yield the floor.
Oh, wow. Okay.
Yeah, I can chime in. I agree with Stan. Colonizing is a big deal. It's, people compare it to some of the early expeditions of these pioneers crossing the United States. And, as Stan pointed out, there was always at least water somewhere available and air to breathe and animals you could hunt and things like that. So, you can tell a technical story of how you might colonize somewhere. And of course, we have these visionary people right now that are attempting to build the infrastructure to colonize cislunar space. In the case of Blue Origin, or in the case of Elon Musk, he wants to go and colonize Mars. He said he created SpaceX in order to do that. So one thing I've learned about people like Elon Musk, don't count him out. He's done all these things that people said were impossible. Colonizing is going to be another few quantum levels, though, from the things that he's done. I have a feeling he's going to get to Mars, get humans to Mars. But, colonizing, you can tell that technical story of how you might get nuclear reactors launched, how you might crack underground water into oxygen. But the devil's in the details. And for the people who say, well, we've got to be able to colonize in order to get humanity off this earth before we ruin it, I am in the camp that says it's a lot easier to figure out how to fix the earth or stay living on the earth rather than to go and colonize a place like Mars. But having said that, I'm all for exploration and look forward to seeing what kind of progress will be made and can be made.
Very interesting.
So what if I take out the word colonizing a little bit so we could talk about it a little bit more? This is, we're talking about the 2030s and 2040s panel. So I think when we start talking about colonizing another planet, we have to think much farther out, and maybe something has forced us to that point, right? And then we don't have a choice. But I agree with all the comments about, technically, there are steps we have to take to get to that point. And while we're here, those are the steps that we're going to work towards and learn more every time we do it.
Yeah, I think that if I could add that, colonization is a very strong word. We haven't colonized the Earth's atmosphere. We haven't colonized the ocean. There are a lot of places that we operate routinely, and we have the technology in place to do that. And I don't think it takes away from our investigation of those environments to not have achieved homesteading, if you will, in the atmosphere. We still utilize aircraft and people routinely fly around the country. I think that the biggest change, and we're seeing it right now on the commercial space front, the access to low Earth orbit, has been the reusability of a spacecraft and of a rocket booster in a way that maybe while the space shuttle was reusable, it didn't have the capability to do so at a price point that allowed kind of a wider audience to participate. And so I think colonization and in some sense homesteading is too strong of a word, but what might still be, kind of a game-changing, a world-changing, civilization from our perspective changing, routine access to space that I do think is just on our doorstep. And whether that's low Earth orbit or cislunar or a lunar surface or Mars, that access will change our civilization in ways that are, I think, on par with what homesteading in one of those locations would do.
Okay, I guess my comment would be that, if there's money to be made, it's going to happen. And I think it's going to happen in a big way. What drove the development of the Western exploration towards the West was the profit motive. And the profit motive is a very strong motive. And I think that's what's going to really put a flavor of space in the 30s and 40s. Is really it'll be a place for business. And that's going to drive the colonization that we all talk about.
Very interesting that we do have such unique answers. I like to hear them. The next question I'd like to ask then is, if not colonization specifically, what would be then the next biggest milestone that will probably take over the 2030s and 2040s? anyone's free to go.
Yeah, I think the next big milestone on everyone's agenda is getting back to the moon, learning some lessons there, learning some operational lessons there, and then the big one is going to be getting humans onto Mars. And so, I like to say, which unfortunately is true, is that we've been 20 years from Mars since 1969. Back after the Apollo 11 moon landing, everyone was certain by 1990 we'd be on Mars. And unfortunately, we haven't even been back to the moon since 1972. So I'm hopeful that especially commercial outfits that have motivated leaders that are in the position to basically give directives, like SpaceX, we're seeing that Elon Musk is working on right now the Starship and the Falcon Super Heavy, designed to be a fully reusable system. And I think that hopefully with NASA participation and partnership, we'll see exploration of the moon and the Mars with humans. I'm hopeful within my lifetime.
Let me put in a plug for my favorite. Oh, go ahead.
To me, the major milestone I think that's needed is power and propulsion. Those two ingredients are going to be fundamental to enable this outward moving of humanity into space, power and propulsion. And I'm glad to see there are two reports that just came out from the Department of Energy and the National Research Council that strongly endorse the development of nuclear power, both for nuclear thermal propulsion and nuclear electric propulsion. I think those are the key ingredients that are needed to make this happen. Sorry, Stan, I kind of interrupted you.
Oh, no problem, sir. Usually on a panel, you can kind of look at the people next to you and get a cue, and the Zoom challenge. So I used to study asteroids for a living, and I want to put in a plug for my topic of study there. So a little harder than the moon and a lot easier than Mars. There are a whole bunch of smaller objects that populate space around the orbit of the Earth. Some of those take less propulsion capability to get to than the surface of the moon itself. A good fraction of those are made out of materials that have a lot of carbon, a lot of water in them. And I think the resources that near-Earth asteroids contain are going to be a key part of the puzzle towards expanding into space. Even with reusable rockets, getting stuff off the surface of the Earth is difficult. We can start getting some of the resources that we use a lot of in space, such as water, volatiles such as nitrogen, hydrogen, oxygen, carbon. More and more these days, airplanes are being made out of carbon. And as soon as we can do it, I think our rockets are going to be made out of carbon as well. All those resources are available on asteroids, and they are easier to get than stuff that's on the surface of the moon. So I think that's going to be a key part of our puzzle towards more expansion in space, which is in situ resources that we find and use in space, and especially those on small asteroids.
I think that, kind of going back to Franklin's comment from the previous question, it's really maybe not destination specific, more so it's going to be the first company or area where sustainability is determined, right? And so whether that's in low Earth orbit, which right now has a little bit lower activation energy because rockets exist that can get back and forth, reusable vehicles exist that can get back and forth. And so potentially if you can find the commodity that drives people in that direction, and it's not quite the same to have a company that sustains itself with government dollars to accomplish a mission like we've done for years with NASA or the other space agencies around the world. We need a company that relies on private citizens to actually perform the funding. That's different than the model that SpaceX has right now, but it is a model that I know that they are pursuing to look for customers outside of the government and to develop a sustainable business model that allows them to access low Earth orbit. That could come at another destination, and I know that NASA's plans as we move further out tries to create that infrastructure that allows other visitors, if you will, to kind of participate with the goal to not drive ourselves into a situation where the only customers are governments. The customers can be people who are outside of that. And so the first companies that start to crack that code as to the commodity, whether it's tourism, whether it's mining of some sort, it's that commodity that allows a company to be self-sustainable.
Okay, I don't even know how I'm going to follow all of that. I felt like we were all over the place. I guess, you know, like from the commercial standpoint and finding the resources, I think that's important and definitely like a huge next step. But in parallel, it's like all the plans for the moon are going to help advance all the technologies needed in order to do these other trips, you know, to the asteroids and to Mars and to keep that moving. So it really is going to take everybody, you know, both NASA and the commercial entities to make those advancements and to have, you know, the private sector just, you know, space tourism and, you know, finding the places where the money is going to come from to do all this. You know, it's going to take a little bit of all of it to make it happen.
I like all of these answers. The breadth of them are very unique in each and every way. I heard like lots of answers dealing with just these different various technologies. In particular, what I'm pretty much interested in is that, you know, if we had essentially a launch window in the summer of 2020, essentially, if it were to go towards Mars, it would essentially arrive around 2021. And if it were to come back, it would probably take around early 2023. Obviously, this is a large and long voyage. What do you think kind of technologies and medical techniques would be needed for such long flights?
Well, what a lot of the public doesn't realize is the biggest technology, the long pole, if you will, for getting crews to Mars and things like that, because of the length of the expedition, because of the radiation environment and other harsh environments of the microgravity environment, the biomedical effects are going to be the biggest challenge. And that's one reason why I think we need to continue to operate space station as long as possible to develop these biomedical countermeasures. It turns out not just the radiation, but even the zero-G or microgravity environment is not good for living systems that evolved and adapted here on the Earth in 1G. And so we've got to figure out these biomedical countermeasures in order to facilitate keeping people healthy to be able to go and complete these missions. These probably looking at 500 or 200-2-year kind of time frame missions because of the way the planets line up.
Go ahead, Mr. Love.
So for years, I was the crew astronaut office representative on all of the studies for future deep space missions, including Mars. And I have a little list of all the technologies that we don't quite have yet that we're going to need to go to Mars. The top one, I'm going to let Franklin talk about later because it's propulsion, and that's right up his alley. But I want to mention one that I don't think folks would think of right off the bat, and that's food. So when you're isolated, confined, and the work is hard and you're under a lot of stress, very soon it becomes all about the food. If you read the journals from the polar explorers from 100 years ago, after a while, their journals were about nothing but the food. And if the food was good, they had a pretty good time. And if the food was bad, they were miserable. And you see this on the space station now. The most popular item on space station tables, the hot sauce. And there's also a problem with storing food for long periods of time, like a 3-year mission to Mars. If you dry food, thermal stabilize it so that it doesn't need refrigeration, you can't carry heavy refrigerators, it starts to lose its nutrient value after about a year in storage. And so after that time, you can still eat the food, it'll still taste okay, but your body's not getting what it needs. The way we would solve that on Earth for long duration would be to freeze food with the full water content. But a day's worth of food with full water content is really heavy. A freezer is really heavy, and the heat rejection equipment for a spacecraft to run a big freezer is really heavy. So we have this strange little problem that no one's ever going to think about because it's all about the technology for how to keep crews fed and with proper nutrition on a 3-year voyage from Earth with preserved food and no freezer.
All right. Now, would Dr. Cheng Diaz, would you like to speak?
Well, we got to go fast. We got to go really, really fast. And we want to be able to, grow the food on board, and that all is possible with abundant energy, power. So, power, electric power is fundamental for anything that we do out there in space. And of course, propulsion allows us to go fast. Those two pieces are, in my opinion, number one and number two items of work that we have not done our homework on. We've spent 50 years waiting for this stuff, and we've wasted a lot of time. It's time to move and get those technologies in the forefront. I don't know what else I can say on that. That's my take.
Well, quick question, Dr. Diaz. Do you think that chemical propulsion will be the only means toward moving fast, or do you think there'll be other forms of propulsion that'll be much more efficient?
No, chemical propulsion will be with us for a very long time, and it would be good, and it's getting cheaper. I mean, that's great, but it will be only good for landing and taking off from, the planets, and landing on the Earth and taking off from the Earth, landing on Mars, taking off from Mars, and so on. But the interplanetary journey, the transition from Earth to Mars. You don't want to do that in a chemical rocket, because it's basically all you're doing is just firing a big cannon. So you're traveling in a cannonball. That's not a very good way to travel. You want to go with much more advanced propulsion systems, which are enabled by nuclear power. So nuclear electric and nuclear thermal. Nuclear electric, to me, in my opinion, is the end game. That's where we need to go. There is also some embodiments of nuclear thermal, which will be maybe not as good as the nuclear electric, but they will be a little bit better than the chemical rocket. But nuclear electric is something that we have ignored for a long time. And high power, I'm talking about multi-megawatt, electric, plasma engines driven by nuclear reactors. That is what we need to develop to be able to go to Mars and beyond, go fast, and have enough power on board so you can grow your food and be comfortable, healthy.
Thank you.
I think I would add that the destination is important here, right? And so it's not necessarily the journey that we hope to achieve, it's the destination, and some time to loiter there and to return. And so speed helps us get to what we're specifically looking for. And it helps address the point that Leroy brought up about the health of the astronauts who go on that mission and come back, because you're in some sense going to be limited by how long they can be in space in that environment that they didn't evolve in, and what that does to their biology, to their system while they're on their way and on their way back. You'd like them to have that degradation actually performing the mission and maybe not the trip back and forth. I would add that on the medical front, the monitoring of the health of the astronauts, I think, is in many cases, that is going to be the solution to some of our problems, to be able to detect early when things aren't necessarily going right, so that we can deploy our countermeasures. It's been a struggle even on board the space station, which isn't that far away, and we get our crew members back routinely to take the right medical equipment or have the right measurements in place, so that you can tell how well the astronauts doing, how their eyesight's being affected, what the bone density is changing too. Just many things that you would want to be able to monitor if cancer for an astronaut is developing. We all know that early detection is better in terms of addressing that. And so that monitoring of the health of the crew members, both in orbit and when they do come back, is a critical technology that I think is going to be at least as important as identifying any of the countermeasures, because it allows you to address any issues as quickly as they come up.
All right, Ms. Radford, you have anything?
I'll go ahead and pass on this one.
There you go. This will be my last question, and then we can move on to Q&A from the attendees. I would like to ask, essentially, what would the future astronauts of 2030s and the 2040s look like? And what would any of the aspiring astronauts here in the audience, what do you think it would take to become one of them?
I think Tammy should go first since she deferred on the last one.
That's fair. That's fair. I'll start. So I would think that they're not going to look very different from what they are today, right? At least as far as professional astronauts. I think the difference that's going to happen over the years, though, is, having, space tourism take off and having people from more walks of life come and get to experience these things. And those folks are going to come in with the different backgrounds and have to go through some of that same training. So I think that's where the difference would come in, not so much as far as, the professional, this is my career type of thing.
So I think the astronauts that are getting ready to be the first to land on Mars in the 2030s and 2040s and maybe go out further into the solar system are going to look very much like the astronauts of today. But I think that they are going to be the minority of the people in space in the 2030s and 2040s. And the majority of the people in space in the 2030s and 2040s are going to look like airline pilots and flight attendants and hotel operators and miners and heavy equipment operators. Again, I like to compare space to Antarctica. Back 100 years ago, Antarctica was the equivalent of the moon. It cost the world to go there. It was worth your life to see it. And now there's a small town down there, and the folks you meet down there are the ones that are running the sewage plant and keeping the generators humming and cooking the meals. And there's also a few scientists down there doing some work. So I think you're going to see a wide variety of jobs in space that look like, mining jobs in remote locations on the Earth and infrastructure maintaining and building in remote locations on the Earth.
My hope is that the spectrum looks, and I use maybe the scuba or the diving analogy, where hopefully as we continue to go forward, we'll have the full spectrum of participants, right? You'll have people who swim on the surface of the water, or maybe who are at the edge of the pool. You'll have people who put on a mask and a snorkel. You'll have people who take air tanks and go down. We'll have people who wear a hard suit or a submersible vehicle and go thousands of feet underwater. We'll have that full spectrum of folks operating in space, and it's going to take, you'll be able to, recognize that if the person's got their Hawaiian shirt on, they're in a specific category, and maybe somebody else who's wearing a hard suit is at the very other end of that spectrum. And we don't quite have that right now. Even some of our fun-loving astronauts that did wear Hawaiian shirts on shuttle missions, they were much more in that category of the hard suit deep divers, and we want to see that full spectrum of folks in space.
Yeah, I think if you look at the vision of Jeff Bezos, he very much wants to make colonies in space and cislunar space and have that whole spectrum of people that the other panelists have been talking about. But even he admits that's going to be probably hundreds of years from now. And so I think in the nearer term, the explorers that go to Mars, I agree with the other panelists. They're going to look a lot like the astronauts today. Basically, you need someone who's flexible, who can become a jack of all trades. And most importantly for these long duration missions is able to get along with others and work as part of an effective team. When we were flying 2-week shuttle missions, you can get along with anyone for a couple of weeks, but the Russians learned back in the 1970s, you couldn't just throw crews together. You've got to make sure you get the right mix of personalities and the right features to make sure that you have that compatible crew and they are able to continue to work effectively together over a long haul.
Anyone else? Dr. Chang-Diaz? No?
No, I think it's been said perfectly. I mean, everybody's got that's exactly right. I agree with everything.
Awesome. Well, I'll now move on to some questions that the audience has. Now, Congressman Pete Olson has a question for Dr. Chang-Diaz. We meet in webinar at Ad Astra in 2010. Since then, your plasma fusion propulsion, or VAS-IMR, has added importance for HSF. Washington seems to have humans on Mars as the next goal. Our current propulsion gets us to Mars in a multiple of months, maybe 1 year. We need water and food for almost 2 years. Radiation exposure for years too. Your system can get us to Mars in weeks. Is NASA including you in Mars planning?
Well, I hope they are. Yeah, we do have one contract with NASA, and most of the work that we're doing is privately funded, but we do have some collaboration with NASA. And I know that they're looking at the high power electric propulsion end of the technology that we're doing. There's another piece that's missing that we are not developing, and that is the nuclear reactor and the power generation hardware that enables you to connect the engine that we're developing to it and have an electric rocket that's very powerful. That needs to be done by somebody else. And that is a subject of great discussion at the government level. I think NASA is very interested in this. And I have to also say that, we've been very centric to NASA in the United States, but, there are other space powers developing and developing fast. And I'm not just talking about China, I'm talking about, the rest of the world. We have a spacecraft from the United Arab Emirates orbiting Mars. We have a spacecraft from India orbiting Mars, and of course China, and then the Europeans as well. Japan has done just remarkable achievements in deep space exploration. So this is an international, global effort, and we need to think that the flavor of space in the 30s and 40s is going to be very different from what it was, during the Cold War, when it was just a competition between two superpowers, the US and the former Soviet Union. It's going to be a totally, global effort with many, many nations joining in. So I think we must not forget that that aspect of the program.
Thank you. I'll move on to the next question by Yazan Samara. Hopefully I'm saying that right. He asked, what is the future of additive manufacturing, otherwise 3D printing, in the future of space exploration? Go ahead, Dr.
I can talk about that a little bit. So I think additive manufacturing in space is going to be awesome, and it's going to be everywhere. I think the first person who figures out to 3D print a centered regolith brick on the moon is going to be the winner, because we can build roads and landing pads and Quonset huts to put inflatable habitats in and basically make whatever we want on the moon. It's a little bit harder on asteroids because there's not enough gravity to hold things together. But I think additive manufacturing has a very, very bright future in space, especially because we can build a robot that builds things, not have to worry about life support for human operators, and get a great deal done so that when we do send the people, much of their infrastructure can be waiting for them when they get there. So 3D printer you can build on the moon that prints with regolith, that would be a very good thing to have.
I'll follow that up with the whole additive manufacturing doesn't just help us build things for there, it will also help us build spare parts if things break, or especially I work on the suits. So we're always thinking about, you know, if we have ORU components on there that can be replaced, removed and replaced, if they have limited lifespans, that's another thing that will be just immensely useful for.
Anyone else? All right, next question. Jonah Blunt asks, in other words, do we see a second space race in the future? Oh, I'm sorry, that was the second part of this question. But please, anyone?
Well, I guess like I said, I hope not. I hope it's not a race. I hope this is space becomes the place where humanity really comes together, because it is a matter of survival for all of us to be able to, colonize space. I'm talking 50, 100 years from now. The Earth is not going to be able to sustain a growing, demanding population with, the limited resources. So ultimately, humans are going to live outside of our planet, and it's got to be space for all, not just, one or two superpowers, and turn the thing into a military arena. That's not what we want. So hopefully we will not have a race, but we'll have a collaboration.
Yeah, I'd like to add that, I think the conditions were unique for the race to the moon between the US and the Soviet Union. And it's hard to see those conditions existing again for that kind of a thing. And I agree, it'd be better to work together collaboratively. All you have to do is look at the International Space Station to see that we've had such a successful international framework with former Cold War, former World War II enemies coming together on this program that has been so successful. I mean, it even went together a lot more easily with fewer hiccups than those of us that were in the thick of it expected. And so I'm hopeful that we'll be able to do more collaborative work together. Political climate today is not necessarily the best for that, but we're going forward with exploration programs with our current partners, and the commercial companies, I think, are the wild card, the SpaceX and Blue Origin efforts, and perhaps others in the future as well. Those may actually be the first. In fact, they likely would be the first to get us back to the moon and back to Mars.
I think that, Leroy, you really hit it right there, that I think there will be a continued race, and it's for that profit that Franklin mentioned earlier, and it's about these companies. And it would be interesting to see a collaboration between Bezos and Musk to see how that would go between Blue Origin and SpaceX. I think there's a strong motivation for that profit, and I think that can be done in a healthy way that allows more access to space by more individuals, like iPhones and Android phones. For the customer, which is folks who are looking for that opportunity to get into low Earth orbit and beyond on the back of a company or with the aid of a company, that's the race that I see is already developed. And I think that I'm not alone. I'm not original with that idea. It's been out there that's the new race, the profiteers after the nationalist of the original space race.
All right, anyone else? Okay, we have 1 minute left, so I would like to ask one quick question, a really quick one. Do you guys believe that hibernation technology will be something that will be seen in the future?
Nope, we're not built for it. Work straight
right.
for turtles. We're not turtles. There are no there are no primates that hibernate. So I'd be very concerned if somebody says we're going to sleep our way to Mars.
A very quick answer. Well, this is about all the time that we have. I'd like to say thank you to all the panelists for taking their time to come out here and talk to SEDS Rice. We say thank you on behalf of everyone that is here. It is an honor to hear each and every one of you guys give a wonderful answer toward what the future could be like. Now, when it comes to moving forward, now that the panel is done, I like to go ahead and have Dr. David Alexander to discuss the Rice Space Institute. And afterwards, we'll have Ryan come back up and continue with the symposium. Thank you.
Thanks. Goodbye.
Bye, everyone. Good luck.
Thank you.
Well, thank you all for joining us. I would like to invite the director of the Rice Space Institute, Dr. Alexander, and the SEDS Rice faculty sponsor to say a few words about the Rice Space Institute and aerospace at Rice.
Yeah, well, thank you, Ryan. Hopefully you can hear me. I'm having a little bit of connection problems. I'm not really going to talk too long. I'm not going to tell you too much about RSI. You can look us up on the web. But what I wanted to do was, this has just turned out to be another great Hours in Space Symposium. And I think a lot of the credit goes to our students and our student leaders, Ryan and the SEDS Rice team. I want to thank Vanessa for early, and of course our panelists. It's good to see some well-kent faces, and looking forward to the conversation with LA coming up. And again, this is really important for our students, I think, to be able to connect to all of you. And hopefully you'll see how good our students are. I mean, that's one of the reasons for it, the networking and the career opportunities, and just this whole discussion about space. It's exciting times. And again, I just want to give my thanks to everyone who's participated as a guest, everyone who's participated as a host, and the organization. Just, it's again, they've pulled off another great day, and we're really excited that this has proven to be such a good event in subsequent years. So Ryan, that's really all I wanted to say. Great job again with everyone, and just my appreciation. Again, you can't understate how important these kind of connections and these kind of events are for the students and that next generation moving forward. So with that, I'll pass it back to you and we can get on with the proceedings. But again, my heartfelt thanks to everyone.
Thank you very much, Dr. Alexander. Well, now I would just like to let everyone know that starting at 3:30 on the Forager 1 Symposium platform, all the booths will be open, so you will be able to talk to many of the companies that are in attendance, as well as many of the student programs that you just saw, including the Space Studies Master's Program and the Rice Space Institute. I just want to let everyone know that all these booths will be only live, and you will be able to connect with them live from 3:30 to 5.